In this video, we'll talk about how to graph a parabola in standard form. So we say that a parabola is in standard form if it has the following form: y equals ax squared plus bx plus c. So how can we graph a parabola when it's in this form? Well, let's work through a couple examples. Let's say we have y is equal to x squared minus 2x minus 3. How can we graph this parabola? Well, the first step is we want to figure out where is the vertex of that parabola. And to do that, we first want to find the x-coordinate of the vertex. So the formula that we use to find the x-coordinate is negative b over 2a, where b is the coefficient in front of the x and a is the coefficient in front of the x squared. So in our particular example, we can see that b is a negative 2. So a negative 2 would be a positive 2. So we'd have a 2 in the numerator divided by 2 times a. We can see that a is just 1. So 2 times 1. So our x-coordinate will be 2 divided by 2, which is 1. Now to find the y-coordinate of the vertex, we can simply plug in this value of 1 for x into this original equation and see what we get for y. So if we do that, we'll have y is equal to 1 squared minus 2 times 1 minus 3. So we get 1 minus 2 minus 3. So we get 1 minus 2 is negative 1, minus 3 is negative 4. So we know the x-coordinate and the y-coordinate of the vertex, so we can write vertex is located at 1, negative 4. Now, if we were to create a graph to visualize this, 1, negative 4, 1, 2, 3, 4. Here's our vertex. Now we just need to find 2 more points so that we can create our parabola. So the easiest way to do it is let's find our y-intercept, because that's the point where x is equal to 0. So if we find where x is equal to 0, we can find out what the y value is, and we can add a point on our vertical line here. So the way that we find our y-intercept is we plug in a 0 for x into this original equation. So we'll get y is equal to 0 squared minus 2 times 0 minus 3. We can see that all of that is just equal to 3, negative 3. So our y-intercept, y-intercept is 0, negative 3. So now we can add this point to our plot. So x is 0 and y is negative 3 right here. Now it helps to remember that our vertex right here, this parabola will be symmetrical about the vertex. So if our parabola is starting to go curve up like this, and we know that to get to this point right here, we had to go to the left 1 and up 1. We can just go to the right 1 and up 1 to find the point that is symmetrical on this right-hand side of the parabola. So that point would be 2, negative 3. So remember, this point is 0, negative 3. So this point must be 2, negative 3. And now that we know that point, we can go ahead and start to draw a parabola on this right-hand side. So this is what the parabola will look like using just this equation that we had in standard form. All right, let's try one more example. Let's say we have y is equal to negative x squared plus 6x minus 4. How can we graph this parabola? Well, once again, we want to start by finding the vertex. And we can start by finding the x-coordinate of the vertex. And recall the formula that we used to find the x-coordinate, negative b over 2a. So for this particular example, we can see that b is 6. So a negative b would be negative 6. And then in the denominator, we have 2 times a. We can see that a is a negative 1. So negative 1. So we get negative 6 divided by negative 2. That would be a positive 3. So that's our x-coordinate of the vertex. To find the y-coordinate, we simply plug in a value of 3 for x and see what we get for y. So y is equal to negative, we get 3 squared plus 6 times 3 minus 4. So we get 3 squared is 9, so we have a negative, so negative 9 plus 6 times 3 is 18, minus 4. So negative 9 plus 18, that's positive 9, minus 4 is 5. So now we know the x-coordinate and the y-coordinate of the vertex. So we'll write v vertex is equal to 3, 5. So now, if we create a plot to visualize this parabola, we know that the vertex is at 1, 2, 3, 1, 2, 3, 4, 5. Here's our vertex. So now we need to find a couple more points so that we can actually graph this parabola. So remember that we said one trick is that we can find the y-intercept, because that's the point where x is equal to 0. So let's find the y-intercept. We'll say y-intercept is equal to, we plug in a 0 for x into this equation and see what we get. So negative 0 squared plus 6 times 0 minus 4. We can see that both of these terms are 0, and we're left with negative 4. So the y-intercept, we'll write y-intercept is 0, negative 4. So if we plot that, here's 0, 1, 2, 3, 4. Here's our y-intercept. So if we graph this left-hand side of our parabola, we can see that it will open down. And that makes sense because we had a negative value in front of the coefficient for x squared. So that's a dead giveaway that this parabola will open down. So now let's see what we did to find the y-intercept. From the vertex, we had to go to the left 3. So that means to find whatever value is symmetrical on this right-hand side, we just need to go to the right 3. So right here we're at 3, 5, so we need to go 3 more. 1, 2, 3. Now we know that this y value on this right-hand side will have the same y value as the y-intercept. And recall the y-intercept is 0, negative 4. So over here we will have, let's see, 1, 2, 3, 4, 5, 6. So this will be 6, negative 4. Since this value needs to be symmetrical about the vertex. So then we can draw this right-hand side of the parabola as well. So that is how we can graph this parabola using only this equation in standard form.